Alright, this is a example of Simpsons Paradox. So for instance, some college somewhere, they have some stats on being accepted into the school split by, men applying and being accepted and women applying and being accepted. And we're going to talk about their rates of acceptance. So the percentage of men that are accepted is going to be the number of acceptance, which is the 125, out of the total number of people that or men that applied, which is 165. Now remember, to change fractions into percent, you do a division, and you turn around and multiply by 100, and don't forget to tack on the percent. So if you do 125 divided by 165 and multiply that by 100, you end up with 75.8. So this is a total of 78, oops, I said 75, 75.8% of men get accepted into the school. Alright, so if we do the same thing for the women, we find that the women, 158 of them were accepted out of a total number of applications of 201. So you multiply that by 100% and see what kind of percentage you get out of this. So you get 158 divided by 201, multiply by 100, and you get 78.6. So we can say by this percentage that basically the women have a higher acceptance rate than the men. Yeah, write this all down. There we go. So the women have a higher accept rate than the men do. Alright. The problem with this is it shoves the men and women into one category. So what happens is if you can split it apart into maybe the different programs or the different degrees, you might see something a little bit different. So if we go and split it all up into the AS degree, the AA degree, and the AAS degree, and up top are the men and women that were accepted into each one of those programs, the bottom part here is the number that have applied to it. And here's those total numbers that I was showing you earlier. So basically this accepted total 125 is the sum of those three numbers right there. And the total applied, this 165, is these three numbers right here. So if we individually tackle the percentage of people that were accepted in each one of these groups, I should have moved the numbers over, what you're going to get, and I'm going to shortcut a lot of this, is if you look for the percentage of men that were accepted in the AS degree, it would be 56 divided by 77. So 56 divided by 77 multiplied by 100. That would be 72.7%. So I'll just write that here, 72.7%. Alright, if we do the same thing for AA, that would be 32 out of 50. So 32 divided by 50, multiply by 100, and you get 64%. Even. 64%. Here it would be 37 out of 38. That's like 90 something. 97.4%. Alright. For the women, change colors here. Let's do 36 out of the number applied, which is 50. So that would be 36 divided by 50 times 100 is 72%. Now remember, the one above here is 72.7%. So here the men did better than the women. Alright. This one here would be 41, that 41, divided by that 65, the number accepted out of the total number applied. So 41 divided by 65, 63.1%. And again, the men did better. Alright, here the last one, 81 out of 86. So 81 divided by 86. You get 94.2. 94.2%. And again, the men did better than the women. So after you break this all down, we started off with the women had a higher accept rate totally at this college, but if you look at each individual program, the men did better than the women. So this is an example of Simpsons Paradox, when things flip. So together, women better than men. And then separate, or separate, men better than women. Things flipped around. This is what happens with Simpsons Paradox. If you look at it all grouped up, it becomes one type of relationship. When you separate it out, the relationship either flips or shows very little change between the two of them, like they're even 72%, 72%. So this is a Simpsons paradox, and it can go both directions, where the separate information tells you one thing, but the together information tells you totally different. So if this happens, we say that there is a Simpsons paradox. If it doesn't happen, then it's not evident. So this is Simpsons paradox evident. Because it's switched. You know, who's better? It's switched. Well, I hope that helps with that.